Hello everyone. Today we are going to discuss about the discrete mathematics, PCNF and PDNF. So first of all, we infer the disjunctive normal form. Disjunctive normal form is nothing but uh, P and Q. So any two variable is operator, the AND operator, it is called the min term, and the sum of product of canonical form is called a disjunctive normal form. So any given statement after implementation of the suitable formulas, which is equivalent to the logical equivalences formula, we derive this as the sum of product of the sum of product of the statements. So this is called the disjunctive normal form. So this disjunctive normal form is promoted to the principal disjunctive normal form whenever each means term of this given after simplified term is contains all this is described variables. For example, any statement given in the three number of variables p, q, and r means every min term of this problem or the given statement is contains p and q and r. It is called the principal disjunctive normal forms. So another example problem here we are going to discuss uh, negation p or q. Then P and Q are negation P and R or Q or R. So P negation P or Q to be discussed, we consider first. We just notice that this negation P and Q are a individual min term. So this is in the DNF, disjunctive normal form. Already it is in the form disjunctive normal form. We just extend this into the principal disjunctive normal form. For the first min term, negation P is not available or not contains a q, so we include this uh, q variable by considering or by operating and to negation q or negation q. And similarly for the second minterm q is p is not available, so this is to be included by the operator and with p or negation p. By the distributive law, negation P and Q, or negation P and negation Q. We reach this the two min terms. And second, Q and P by the same distributive law, we reach the Q and negation P. So here, the term, which one is repeated? I think this P, negation P and Q, these two terms are repeated. So we have to write only one times, because negation P and Q are negation Q and negation P are is the same P. That is P or P is gives P. So negation P or Q, and as next min term this one, and next min term to be described, we have to follow the same thing. This is becomes the principal disjunctive normal form, PDNF. Okay. And next, the second problem, P and Q are negation P or R, or Q and R. Okay. Now we just already this P and Q, negation P and R, Q and R. These three terms are disjunctive normal forms. This is disjunctive normal form, because these three terms are min terms. Okay. So sum of product of the min terms are that. So it is called a disjunctive normal form. So we just include the first min term into R variable by introducing R or negation of R. And for the second min term, we introduce or we include Q variable by considering Q and R negation of Q. And for the third min term, Q and R, P to be included by P or negation P. By the distributive law of this statement, we get this statement. Now we discuss the principal conjunctive normal form. So principal conjunctive normal form is nothing but is a product of a sum of canonical forms, or it is called a product of max terms. So the possible max terms of the three variables P, Q, R are listed here. Then we are going to discuss the first example. Find the principal conjunctive normal form of the formula is by negation P conditional R and Q by conditional P. So we consider this given statement and we implement the negation, that is a biconditional statement of this. Biconditional is Q conditional P and P conditional Q. And next we implement the conditional statement negation Q or P. And P conditional Q conditional statement or equivalence relation is negation P or Q. By using of we just notices this is a max terms. So we have the three max terms, and this is called in this stage we conclude this is a CNF, conjunctive normal form. So this conjunctive normal form to be extended to the principal conjunctive normal form by introducing the which variable is not available in this max terms. So for the first max term PRR, PR, there is P R variables are there, Q is not available. So we just include by Q and negation of Q. And for the second max term, R variable is not available. So we include this by R and negation of R. And for the third max term, R variable is not available. So R and negation of R. So applying the distributive law of this is the three cases, and what are the terms are repeated. So we just omit this more. We keep this one times of this max terms. Then we consolidate all these things. We get this is the principal conjunctive normal form, PCNF. So at the same time, how to be determined? So for this problem, we find the principal conjunctive normal form. But my question is to be raised here is, what is PDNF of this statement? So this is going to be discussed further. So from the PCNF to PDNF conversion is this case. So what we are going to discuss is from the now the conjunctive normal form of negation of S. First of all, this is the given statement yes. We take this a negation of the entire statement yes and obtained by writing the conjunction of the remaining max terms. Thus negation yes has the principal conjunctive normal forms. Okay. So next term that is this. It is out of the we listed in the previous slide. Eight number of the max terms are there. So out of this eight number of max terms, so what are the terms are repeated, or what are the terms to be cancelled from this principal conjunctive normal form? What are the terms contained in this conjunctive normal form? We omit this the max terms and we write this the equivalent minimized, that is min term of this out of this eight combinations. Then we take this the negation of again. This is becomes a conjunctive disjunctive normal form, principal conjunctive normal form. So vice versa, we are going to discuss or we just find the PDNF to PCNF by the same manner by eliminating this min term from DNF to from the out of this eight possibilities, we convert this into the remaining max terms and we consolidate this, we get this the principal conjunctive normal forms. So another example of the finding of PDNF form and PCNF for the statement P R negation P conditional Q R negation Q conditional R. So this is a given statement yes. So we implement the negation Q conditional R. The formula is negation of negation Q R R. And negation of P conditional this is equal to negation of negation P R Q R negation of negation Q R. By double negation formula, the negation of negation P is P R Q R. Negation of this negation is Q R R. So Q R Q is Q, and next step P R P is also P. So this P R Q R R is a max term. So this max term is a single term which just becomes a CPCNF, principal conjunctive normal form. We just promote this into the principal conjunctive normal form to the PDNF by considering or the conjugation of the remaining max terms. So already we list out the eight number of possible max terms of the contains three variables. So from this list out of eight, we omit this statement, that is this max term P or Q or R. We write down the remaining seven max terms. So this remaining seven max terms with negation again, this is becomes the PDNF. That is called negation of PCNF of negation of S. So we just entirely take that's a negation of the each and every operator as well as the variable. Complete negation statement is becomes a PDNF of this given statement. And this is also another example of finding a principal disjunctive normal form PDNF of this given statement. The P conditional Q and negation of negation Q or negation P. So this is equivalent to P conditional this. So this P conditional means negation P or P conditional Q and negation of negation Q or negation P. So negation P. So this P conditional Q statement is negation P or Q, and we just take by De Morgan's law negation of this negation Q and negation of negation P. or by the just take this a negation of the this two q and p, we get this a double negation of q and p. So this is by the De Morgan's law. So PR negation of PRQ and double negation of Q and P is P and Q. So PR negation of P, P and Q by the distributive law, Q and P and Q. So this negation of P and P is a false. So false and Q is also false. Q and P and Q. Okay. Then now, so negation of P are P and Q by the distributive law. We get negation of P and true are P and Q. So because this negation of P is a min term and P and Q is just another min term. So we introduce the Q variable into the first min term. So negation P to be operated and operated with true first. This true can be replaced or we equivalently take it Q or negation Q. By then again by the distributive law negation P and Q and negation P and negation Q. This one or P and Q. So we reach this, three variables or three min term. So therefore this is called PDNF of the given statement or the given problem. Right. So like this, the successive or the suitable formulas is to be implemented. Then we get this is the principal conjunctive normal form or the normal forms. Next is the principal, one of the problem finding a principal disjunctive normal form PDNF of this given statement. P and Q are negation P and R or Q and R. So we just notice this given statement, this P and Q, negation P and R, Q and R are a min terms. Already it is in the proper min terms are there. So this is here DNF, disjunctive normal form. So now we just to promote this DNF into the principal disjunctive normal form by introducing the first min term P and Q by true and true, and second min term negation PRR into T, that is and T true, Q and R in and true. So this true to be replaced by which variable is not available in this min term. So R variable is not available. So we replace this T as R and negation of R. So similarly for the second min term, Q variable is not available. So this T to be replaced as QR negation of Q. For the third min term, the P variable is not available. So we introduce PR negation of P. By distributive law, P and Q and R, P and Q and negation of R. R P and R are Q and P and R are negation of Q, right? And next PRR and P and PRR and negation of P. So we have this a six number of min terms are there. So this is becomes a uh, sum of product of canonical forms or sum of the min terms. If in this out of the six, two number of variables or two number of min terms are repeated, so we just omit this repeated term. So and keep this only one times alone. We get the final, the sum of the min terms is contains is four terms. So this is called PDNF, right? I think This is also another example of the finding a DNF of the given statement contains the three variables P, Q, and R. So by the previous example discussion, we just go through this problem. If you have any difficulty, we just chat it. We give this a explanations about this problem. And thank you so much for the kind listening, and also thank you so much everyone.